All right, welcome to today's lecture. We're going to be focusing on, for the first part, abstract classes and interfaces. And then we're going to be focusing on polymorphism in the second part of the lecture today. All right, so let's get right to it. All right, so first up, generally in object-oriented programming, there are several features that allow for or enhance reusability of the code that you've written. We have looked at inheritance in the last lecture, and from that we know that that allows us to create new classes from already existing classes by extending it there, right? And so that gives you the benefit of reusing something that was already written and then making a version of it that is more specific or adding features as you go along through inheritance or through the subclasses that extend the superclass. So this concept is further supported by what is called interfaces and abstract classes. So an interface really says what methods a class of an object should provide. Doesn't provide any code aside from definitions, but an abstract class has more fully implemented parts, and the other parts that only act like interfaces and say what should be done. So we can mix it up in abstract classes, but we are not allowed to write definitions inside of interfaces. And we'll talk a little more about that. Now, going back to our UML specifications, if we were to specify an interface in UML, we do it by using the following object here, as you see. Note we have the word interface there, and then the name of the interface. And then because we said there are no implementable parts, obviously we won't be able to put anything that are going to be instance related. And so no instance variables are allowed inside your interface. Now the methods inside your interface are by default public, and they are abstract. And by that we mean that there is no definition in the body, there is no code in the body, right? It only has the method header. All right, so in Java, the keyword to create an interface is the word interface. And so you see we have the visibility modifier followed by the word interface and then the name of the interface, and this interface is called doable. Now, none of the methods in an interface is given a definition or a body. So all we have is the method visibility modifier, what it returns, the method name, and any parameters that it takes in, and that's about it. All right. Now, note especially that at the end of writing the method header, we put a semicolon which terminates the line. Not what you usually see when you're writing your methods, right? So far. Again, interfaces cannot be instantiated. So methods in an interface have public visibility by default, and a class formally implements an interface by stating so in the class header and providing implementations for every abstract method in the interface. Right? So if a class declares that it implements an interface, it must define all methods in that interface. So any class, for example, that says it implements the doable interface, as you see here, right, must have a method called do this, one called do that, one called do this too, and one called do the other. Yes? All right, so here's the example in code. In Java, if we wanted can do to use the doable interface, we write the public class name and we say implements the interface, right? Which is doable, which we just created on the previous slide. Notice we create an interface by using the keyword interface, but a class is said to implement it, and that is how we use the interface. And of course, as I told you before, you will now have to make sure that all the methods that are defined, declared in the interface, are actually implemented in any class that implements it. So in UML, an inheritance relationship is used when a class implements an interface. So this is how you would draw it in UML. Just the same way, we use the same arrow, and we carry this special format of this diagram as we did from the previous slide. And all we do is, it can be a class with any name, and its definition would have come inside here. We just left that blank for the time being. All right. Now, a can-do object is also a doable object, since it implements the behavior specified by the doable interface. And so we carry forward the is-a relationship as with regular classes that we discussed last week in inheritance. Now, in addition to abstract methods, an interface can contain constants, which now means that when a class implements an interface, it gains access to all its constants. Remember, we say it cannot have instance variables, because instance variables change with every instantiation of the object, and you cannot instantiate an interface. Okay? A class that implements an interface can implement other methods as well, so you're not restricted only by the methods that have been declared in the interface. You can add methods in your class that implements the interface. So here's an example of an interface called complexity. And note this interface has two methods, the set complexity and the get complexity, right here. So any class that implements this interface must define these two methods at least in the body of that class. All right, so let's say we have a class called question that implements the complexity interface, which we just spoke about. All right, now in this class, we would have created some instance variables, right? But and we have our constructor, right? And now we would realize that the get complexity and set complexity are defined here because it must do that. All right. Now, these methods, it doesn't matter how they work in terms of the body, once they match what is required by the interface we're fine. Okay? And then we have some more methods in addition to those which we had to implement, like get answer, answer correct, and toString, which were not specified in the interface. Now, when we're ready to use it, and this is an example of a driver class, right? With our main method, you recognize that, right? Good. So we create two object references, one called Q1 and one called Q2, and I mean another variable here, and we just accept some answers from the user and carry forward that implementation to give us, you know, a running version of what we just discussed. Now, a class can actually implement multiple interfaces. Remember that last time when we spoke about inheritance, we said a class can only extend one class. Okay? That's for inheritance. But for interfaces, you can implement multiple. And we do that by just listing the classes, right, after the word implements, the interfaces, sorry. So once we say my class implements, I can now write all the interfaces that that class implements, all right? And that will automatically mean that all the methods that are in all the interfaces listed must be implemented inside many things, all right? So I just mentioned that, so I can move on. All right, so Java supports single inheritance, meaning that a derived class can have only one parent class. I just said that also. And multiple inheritance basically is having two or more classes being inherited in the child class. In such cases, you might have collisions, and so you stay away from multiple inheritance. And Java really doesn't allow it. Instead, Java uses interface to allow a class to have characteristics from more than one type of class. Yes. Any questions on interfaces?
No, sir. No, sir.
Okay, we're all good. All right, good. All right, so we move on to abstract classes. Just a moment. All right, so on to abstract classes now. An abstract class, similar to an interface, but there's a slight difference. It's a placeholder in a class hierarchy that represents a generic concept. Whilst interfaces, as we just mentioned, cannot contain attributes, abstract classes can actually contain attributes and can also have fully implemented methods, right? But in addition to that, we can also have abstract methods. In UML, we represent an abstract class, same like we represent other classes, except that the name of the class is going to be in italics, okay? The only problem you have is writing italics when you're writing on the exam paper, so you have to find a way to do that, right? All right, so in Java, we use the abstract modifier on the class header in order to declare the class as being abstract, right? So as you would see here, we have public abstract class product. As a matter of fact, you can write the abstract before the word class or after, or after the word public. You can say abstract public class or public abstract class, right? Either way it works. Now, an abstract class an abstract class often contains abstract methods with no definitions, just like the interface. However, you have to put the word abstract, which we call the abstract modifier, before each abstract method, right? And then you also have to remember that the abstract class can contain non-abstract methods which are fully defined, right? A class declared as abstract does not have to contain abstract methods, however. Simply declaring it as abstract makes it so, and that's fine. And so here's an example, and we're gonna look a little bit more into this example a little later on, but here's a quick preview of the example. Let's say we have a class called staff member, which is abstract, and notice in this case we write the abstract before the word public, right? So that's fine. We have instance variables here that are protected, and we make them protected because we want them to be able to be referenced from a subclass. Yes? And to all others, they are private. Now, in our abstract class, notice we have a constructor here, which takes in all the variables that are required to instantiate a new object. All right, and we copy those in, and everybody is fine, right? We also have a method called toString, which we implement fully. However, we have an abstract method here called pay. All right, so this method is abstract, which means that it must be implemented in any class that implements this abstract class, okay, or extends it. So in order to use an abstract class, you write a class that extends the abstract class. So using an abstract class, you use the same keyword extends as you did with what we call a concrete class, okay? Now, the subclass must override the abstract methods of the parent, or it too will be considered abstract. So if, for example, we write a class with a method that doesn't have the word abstract, right? If we have a class that does not implement a method that has been declared abstract in an abstract class, the class that extends the abstract class also becomes abstract. All right? So not the class that becomes, the method, right, becomes abstract, sorry. So an abstract class can have constructors also, as you saw in the example before. The subclass must therefore invoke a constructor of the superclass, just like we do with concrete classes when we discuss inheritance. So here's a class hierarchy which now uses abstract class. Notice staff member at the top. Based on the fact that this look italics, right? We can assume that this is an abstract class, and then these are concrete classes here, yes? And if we're to implement this, of course, volunteer extends staff member and employee extends staff member, and that is how you would represent that inheritance relationship here. A point to note, which is important, executive, right, will extend employee. An executive doesn't know anybody, any other class except its parent. So the relationship between employee and staff member must be managed between these two, and then executive will manage the relationship from here down. Yes? It is important to note that executive doesn't know staff member. Yes? Everybody sees that? Good. Now, here's an implementation of volunteer based on what we have here, which extends staff member. A volunteer, notice the first thing that we do inside the volunteer constructor is to call the constructor of the parent class for staff member. And we do that by using the super keyword, right? Remember we said that the last time. And then we have to write the details to override the pay method, which we had in the staff member class, okay? So inside staff member, we had pay, which was an abstract method, and so we have written the definition in here, but unfortunately volunteers get 0 pay, yes? Employee, however, notice we do the same thing here, but employee has additional variables defined inside the employee class, instance variables that they are. And notice the employee constructor takes in all the variables for the staff member class, right? In addition to the variables for itself. So notice now the constructor for employee takes in all the variables for its parent class and all the variables for itself. And then what we do, same thing again, we call the constructor from staff member, which is the parent class, as the first line of code in our constructor for employee, right? Because we extend staff member, okay? And then we set up our other instance variables, which are specific to employee. Right? Same thing happens for executive, all right? The executive now have one instance variable, which is bonus. And notice again, we take in all the variables required for the parent class and also for the executive class, and then we make the updates as necessary inside the construct. All right. Now, a few other points to note. An abstract method cannot be defined as final or static, and we know why that is so, right? You want to tell me? Because if the method is abstract, it means it must be overridden, all right? And if it's overridden, it can't be final, right? And we talked about the static modifier already. We say anything that is static, right? It means that it is shared among all the objects. So there's a restriction there. Apart from these specifics, an abstract class can be treated in much the same way as another class that is extended or used to create a new or to create a new class. The use of abstract classes is an important element of software design because it allows you to establish common elements in a hierarchy that are too general to instantiate. We saw the example of pay, right? We declare the concept inside staff member, right? A staff member gets paid, right there. But depending on the staff member, right, the pay is defined differently. So the volunteer gets no pay, right? The employee has a pay rate, right? And then the executive gets a bonus in addition to his pay, okay? And so we are saying that every staff member must have something that determines what their pay is. But the specific of the type of staff member that you are is what determines how much, when, and how you get paid. Yes? All right. So that's about what we will cover for abstract classes and interfaces. And we will move on. All right. So now we're going to be talking a little bit about polymorphism. And polymorphism is really an object-oriented concept that allows us to create versatile software design. It's quite interesting, and we're going to be revisiting the previous example to see what makes polymorphism such an interesting and important topic in OOP. But however, before we go on to that, we need to talk a little bit about the concept of binding. All right. So when you write your program, you write it in some high-level programming language, and for this course, of course, our reference is to Java. Now, that has to be translated into what we call machine code to be run on the processor, right, of some computer, right? Now, these steps are really carried out. The steps to get it to that point are really carried out irrespective of whether or not your code is translated in machine code or some other form. In Java, for Java, we use something called bytecode, which is an intermediate type of code, which is then executed by the Java virtual machine. All right. Now, there are many decisions that has to take place as your program is run. For example, each variable that is used must be associated with a location in memory that stores the value that is going to be kept in that variable, right? The code for the instructions in a method must also be located so that they can be processed when a method is invoked during the normal operations of your program. Now, the term binding refers to the action of making an association between a reference to a variable or method and its location in memory, okay? Pay attention to that. Now, binding can occur at various stages of the translation execution process. All right. Now, it can occur when the program is translated, and this is referred to as binding at compile time. Now, if that happens, it makes these bindings fixed and do not change when the program is run. I want you to take a moment to think about that. If they take place at compile time, it means that the association between the method, the variable, and what is stored in them, right, don't change when the program is being run. Alternatively, though, binding can be deferred until the point of execution. And these bindings are dynamic since they can change as the program is run. Okay. Now, obviously, you would want to imagine that Java is such a great language that it does what is called dynamic binding or late binding. So consider the following method invocation. We have an object obj and we invoke the method doIt. At some point, this invocation is bound to the definition of the method that it invokes. You with me, right? If this binding occurred at compile time, then that line of code would call the same method every time. Now, The mechanisms built into Java, such as overriding, right, and implementation of interfaces, create class hierarchies. Some methods might have multiple definitions as part of these class hierarchies. Now, Java requires that decision of which definition of a method should be invoked be deferred until the point where the invocation occurs. This gives rise to what is referred to as polymorphism. Very exciting topic in OOP. So let's talk a little bit about what that means. It really means having many forms, all right? So a polymorphic reference is a variable that can refer to different types of objects at different points in time. The method called through a polymorphic reference can change from one invocation to the next, and therefore all object references in Java are potentially polymorphic. Interesting stuff. So consider the following class declaration. So we have a class called occupation that extends, that extends skill, right? Now, an object type occupation is also of type skill. Why? Because it is an inheritance relationship. And what did we say about inheritance relationship? It is a relationship. So occupation is a skill. Yes? It's a more specific form of skill because it extends, which means it takes on all the characteristics of skill and it may add some of its own. So suppose we create the following reference variable. Notice this is a reference variable. We haven't had an object as yet. See that, right? So we create a variable called job, which is of type occupation, but it's not pointing to an object as yet. So this reference can point to an occupation object, but it can also be used to reference an object of type skill, which is what we are doing here. So we say job, which was declared as an occupation, is set to point to a new object which is of type skill. But remember, because occupation is a skill, it's fine. Yes? Now, this reference is polymorphic, which means that it can mean different things at different times depending on the object that job references. Right? And of course, if you use this really well, you are going to see some very elegant designs in software. And we're going to see a simple example of that in a moment. So then, an object reference can refer to an object of any class related to it by an inheritance. So for example, if holiday in this case, which is a parent class here of Christmas, so Christmas extends holiday, right? Holiday is a superclass of Christmas, then holiday reference could be used to refer to a Christmas object. And see, we have done it here. We have created reference type, day, and then we point that to a Christmas object. Yes? Now, these type compatibility rules are just an extension of the is a relationship. Now, assigning a Christmas object to a holiday reference is fine because Christmas is a holiday. But assigning a child object to a parent reference can be performed. Sorry. So that can be performed by a simple assignment. But assigning a parent object to a child can be done, but has to be explicitly done with what is called a cast, a typecast. So why this is so? It's because Christmas is a holiday, but not every holiday is Christmas. All right? So you realize that you have to make sure you do something special to do from parent to child, right? Now suppose holiday class has a method called celebrate and Christmas overrides it. So let's say, just like pays in our previous example, we have a class called celebrate inside of the holiday class. I remember Christmas actually inherits from holiday. So it inherits that method. What is invoked by the following? Day.celebrate. What is invoked depends on the object type that is being pointed to. And what object type is day pointing to? You can answer.
Holiday.
No,
Holiday.
Christmas. It's pointing to an object of type Christmas. Right? So day equal new Christmas, right? So what will happen in this case is that the version of celebrate that will be executed is the one inside the Christmas class, okay? So the type of the object being referenced, not the reference type, determines which method is invoked. Right? Now the type of the object being referenced in this case is wherever you see the new. Right? That tells you the type. We just created an object of type holiday, but now that object is referencing another object which is of type Christmas. And that is what determines which method is going to be invoked. Right? Now, note that the compiler restricts invocations based on the type of the reference. So if Christmas had a method getTree and holiday didn't have, the following would cause a compiler error, right? This would cause a compiler error. Why? Because day was declared to be of object type holiday. Notice there? So we created day of object type holiday. If holiday does not have a method that Christmas has, right, then we're going to get an error if we try to invoke that, right? Because the parent doesn't have access to it. It is a child that have access to the parent. Now, if we were to do that, we have to now do a cast by putting the actual type before the variable, right? So that we can say, okay, the specialized version of day that we want to, of holiday that we want to use is Christmas. And therefore it tells the compiler, say, make sure you make day of type Christmas and then call the getTree, because that's where the getTree method is going to be. Right? The reason is really that day was declared to be of type holiday, and it could be of any holiday type, because if we had another type of holiday, let's say Easter, then they could be either Christmas, Easter, or remain just a generic holiday. Okay? So, let's do a quick check. If music player is a parent of CD player, are the following assignments valid? All right, let me help you since you're struggling. So the first one is fine because CD player is a music player, but the second one is not fine because what we're doing is to basically assign a child to a parent. And in that case, we have to do a cast. Okay? All right, so let's revisit the example from before. Right? Consider the following class hierarchy, right? Where we have the abstract class, staff member at the top, then we have a volunteer, an employee, and inside the employee category, we have executive or hourly paid people, okay? We're gonna look at some code that is going to illustrate a method named pay that is used on a collection of objects of type staff member, all right? Please pay attention to the details here, all right? Now, the class staff member is declared as an abstract class like before. It cannot be instantiated, but instead will be extended to define the different types of employees, all right? Now, despite this, we're gonna create a constructor like we saw in the previous example, and the pay method is declared as abstract. All right. So here we go, staff member, which is an abstract class. It has some key things. So every staff member must have a name, an address, and a phone number. Basic things. And here we have a constructor. Now, we also have a toString method, and of importance, we declare the pay method. Now, the pay method is abstract, all right? And we use the keyword abstract to designate that, okay? Which means we have to, any class that extends staff member, right, must implement the pay method. So there are 4 types of staff members. They differ in how they are paid, all right? We have the volunteer who does not get paid, as we said before, an employee who has a set salary, an executive who has a set salary but also earns a bonus, and an hourly paid worker, okay? Volunteer, of course, we went through this already. We call the constructor for the parent class, and we set his pay, right, by overriding the method pay as required. Then we move to the employee. We again call the constructor for the parent class, and then we set up the other variables, all right, and we move on. So we have a toString and a pay rate. In this case, pay, all it does is to return the pay rate, okay? Now, that's different from the person who got a pay rate here, who is a volunteer of 0, okay? So 2 different people, one have a pay rate, so they come in and negotiate and they get that pay, but volunteer gets 0. Now here, we have the executive, right? Same thing, we call the constructor, and remember that all the variables that are required for both the parent and the current class must be included in that this constructor here. So we call the constructor and then we set a bonus to 0, right? Now, this person's pay is going to be now the version of pay that is implemented in the parent class, which is a staff member class, and we add that to bonus. Now, so we add, right. Now, remember that an executive is an employee, right, based on our hierarchy, okay? So executive does not extend staff member. Executive extends employee. Everybody sees that? Remember, staff member has an abstract version of pay, but employee has a pay rate. So the employee's pay method basically returns a pay rate, okay? Now, and therefore, what we have done here is inside executive is to apply this version of pay, which is coming from the parent class of executive, and notice executive extends employee. So employee has a method implemented called pay. So how we invoke that method is by using the super keyword followed by dot and pay, and this now is going to run the version of pay that is inside the employee class, which is going to return a pay rate. And then we add a bonus to whatever the result of this is, and that is the payment for the executive, right? Then we reset the bonus to 0 and return the payment, okay? Everybody happy? Now the hourly workers, we need the hours worked, and so we set that initially to 0, and then in our version of pay, we multiply his pay rate by hours worked, right? And we return that as his payment, right? So everybody is happy. Yes? Now, we're going to write a class called staff, which manages a collection of staff members, right? And we're going to use a list to do this. So, for example, the constructor simply creates the entries. In real life, the staff member information might be read from a file or such store, but in this case, we're going to just put them in an array, all right? So here we create a class called staff, right? Which the only instance variable it has is an array of staff members. right? It's called staff list. Now notice we use staff member, okay? Now, how do we actually build this object? Notice our constructor, all our constructor does is to instantiate the array to hold 6 variables of type staff member. And so now we can insert the values inside of that array, which is the continuation of the constructor here, where the first item in staff list is an executive. See that? So we use a new keyword to call the constructor for executive, and we pass in the variables that requires based on what we defined in the class on executive. So basically what we have just done is to invoke this constructor here, okay? Where we have a name, an address, a phone number, social security number, and a rate. All right, and we do the same thing here. We create a new employee called Carla. Then we have another new employee called Woody. Then another who is hourly called Diane. A volunteer called Norm. And another volunteer called Cliff. Happy bunch. Now, what we have done is noting that the person in position 0 is an executive. We want to award a bonus to that executive of $500. See that? Now, unfortunately, because they're all staff members, because remember, our list is staff member, right? And then when we're actually putting them in the list, we make them very specific version of staff members. Because our list expects staff members and the award bonus method is not a part of staff members, but it's only a part of executive, we have to take that object in position 0 and cast it to a more specific staff member in order for the compiler not to give us an error when we invoke the award bonus method. And we spoke about that earlier. Yes?
Yeah.
Good. The other thing here we did is to add hours to a particular staff member here in position 3, right, which is Diane, right? Diane worked some additional hours and we wanted to add those, so we call the add hours method with 40 hours, right? And of course, we have to cast Diane to an hourly in order to invoke this method. Again, not because we did anything wrong, but because hourly is a staff member. Staff list holds staff members, and so in order to run a specific version of a method that doesn't appear in the staff member class, then we have to cast it to the more specific version so that the compiler doesn't give us an error as we try to execute that line of code, right? Now we create a method called payday, which is going to make sure everybody gets paid. Now, I want you to pay attention to this line, because this is the elegance we're talking about. Now, we have a for loop, right, which goes through the list from start to the end, right, and we print where we are in the list. Then all of a sudden, we are now going to show how much the current person in that position is going to get paid. Yes? And guess what? Depending on the type of the object being referenced by the member in the staff list, a different version of pay will be executed. And that makes that line polymorphic. So basically, when it reaches when it starts at the first, the pay that is going to be run is going to be based on what is defined in the executive class. Here, it's the amount that is defined in the employee, then the hourly, then the volunteer, and so on. So automatically, the method that is going to be running is dependent on the type of object that is present inside each position of the array that we use. Any questions?
Nope.
So all of a sudden, we have multiple different object types that inherit from a parent type. And then we have to do nothing special to figure out which is which, because we already set up our classes with our varying pay methods. And so the version of pay that is going to be executed, right, is dependent on the object that is being that current at the current position that is being pointed to, right? So whatever object is being pointed to, the type of that object is going to invoke the type, the version of pay. And so you realize that the dynamic binding of Java is what allows for that. Because if, remember when we were talking about binding, if binding was not done at the point that execution is to take place, then we wouldn't have a situation where a different method would be executed depending on the object type at the moment that the invocation takes place. All right? Because if it is that the link between the pay method was established at compile time, then every time the pay method is invoked, it would run the same code. But because it is only done at the point when the execution is about to happen, then the link to which method is to be executed, which is the binding, only occurs at the moment that execution is to be done. And therefore, when the program recognizes what object type it is, then it creates the link between the code and the variable and executes that. Okay? All right, now the driver class firm, which creates a staff object, invokes payday. And all we are doing here is to creating a new staff here. And then we run personnel.payday, which is basically just invoking the payday method, which we created here. And that was just there to show you what would have happened. So you realize that, for example, the volunteer get a thanks, right? While everybody else is paid, right? A value, right? That is the clearest indication that our program works, right? Yeah, volunteers are the happiest. All right, so let's look a little bit on polymorphism via interfaces. So interfaces can be used to set up polymorphic references as well. So suppose we declare an interface called speaker, right? Notice speaker, and we use the word interface. And remember, we can't have instance variables, and we can't have any method body, or what we call definition. So we only have declaration, which is the method header, right? Followed by a semicolon. So what we're saying here is that any class that implements the speaker interface must have a method called speak and one called announce. That's all we're saying here, all right? Now an interface name can be used as the type of an object reference variable, but it cannot be instantiated. So we can create an object reference variable called current, which is of type speaker. But we can't use a new keyword to instantiate current as a speaker, okay? So the current reference can be used to point to any object of any class that implements a speaker interface, right? So the version of speak invoked by the following depends on the type of the object that current is referencing, right? So when we say current.speak, it can be any one of the classes that implement the interface, right? And depending on which of those, it will run that version of the implemented speak method. So now suppose a class philosopher and dog, which both implement the speaker interface, providing distinct versions of speak method. So in the following code, the first call to speak invokes one version of, and the second of speak, and the second invokes another version. So we create a guest, which is of type speaker, but we point it to a philosopher object. Now, when we say guest.speak, it's going to run the version that is in philosopher. Now, we point guest to dog. So when we say guest.speak here, it is now going to run the version that is inside the dog class. Yes? And all of a sudden, the same line of code does something different because they are now pointing to different objects. Okay? So as with class reference types, the compiler will restrict invocations to methods in the interface. So you can't invoke something that is not defined. So for example, if philosopher also had a method called pontificate, the following would still cause a compiler error. All right? Why? Compiler bases its ruling on the type of the reference. A class would have to be used in this case. Because special is of type speaker. Speaker does not have a pontificate method. So we have to tell the compiler which type of speaker it should look for the method pontificate in. Okay? So unless we had written pontificate inside of the speaker interface, right? I remember we only had speak. We didn't have pontificate, right? So unless we had pontificate declared in the speaker interface, we're going to get a compiler error here. We have to do a cast. So then, having seen all of that, would the following statements be valid?
First three valid?
You said the first three are? Any other thoughts?
I thought the first three look good, and the last looks bad. The last one don't look good.
Okay.
Yep.
First is of type speaker, right? Second is of type philosopher. Remember, a philosopher is a speaker, right? So we can put second, which is a philosopher, into first. If we're doing first into second, then we'd have to do a cast. Okay? All right, so that brings us to the end of today's lecture. I'll take your questions if you have any.